Hello, today I'm going to show how to make custom libraries in Python using the importlib module. And I'm going to make a script that multiplies two matrices, and this is sort of how I think of it. You take the first matrix and you form a vector from the first row, and you're going to first dot that with a vector formed from the first column of the second matrix, and that single dot forms a new entry. Then you do it again with this column here, and that forms the end of the row of the new matrix. And then you start at the second row, you dot with the first column, that's one entry, and the second column is the last entry, and you'll end up in this case with a 2x2 matrix. So I'll just make a blank script from scratch to show how to do that. I'm going to define my matrices using a list of lists. So I'm going to just start out with an empty list, and I'm just going to start appending rows. So the first thing I need to do is I need to convert the rows of this second matrix, or excuse me, I need to convert the columns into rows. So this 7, 9, 11 will become the first row, and this 8, 10, 12 will become the second row. So let's do that and make a new empty list. And I'm going to check the width of the second matrix here. But before I do that, I need to make sure it has width. And then I'm going to start iterating through the rows. I'm going to create a new empty row, and I'm going to start adding entries, but I'm going to add the columns. And then once I've made a new row, I'm going to add it to the resulting matrix. And then I'm just going to overwrite the original, and I'll print that and see what it looks like. Okay, so now my first row looks like my original first column, my second row looks like my second column. And another way to think of this is if you sort of mounted this like on a swivel, and this swivel goes down and to the right at negative 45 degrees, and in 3D space you just grab the bottom left and you just pull it up to the top right, and that is sort of what you would get here. So now that I've converted the columns to rows, I can start dotting these two matrices together. I'm going to dot this row with this row first, and then this one, and that's the end of the resulting row, and this row again with the first and the second. So I'm going to create a new empty list. And I'm going to check the width of the first matrix. And you have to make sure the size of the matrices match. And then I'm going to start iterating through the rows of the first. Create a new empty row. And I'm going to start dotting it with the rows in the new second matrix. I'm going to add a new entry for the result. And then I'm going to add the row to the resulting matrix. And here's where I need to generate an error. If my sizes aren't the same, then they can't be combined. So I'll print an error there, and then I'll print the result. And it's not what I meant to do. There we go. Okay, so hopefully that's correct. I think it is. I'm going to leave that. So the point is that now that I've got a working operation for combining two matrices, if I wanted to do this again, I could copy and paste all this code again, or obviously Python has functions for calling this code again without having to rewrite that. So let's define a new function. I'm going to call it and my MATR for matrix, and I'm going to make 2 parameters for each of the matrices, and I'm just going to cut and paste all that code into here. And that should work basically the same. Just have to call it. So mat1, mat2. Obviously I need to return the result. There we go. So another thing I can do with this is I can pull out this dot product and put it into its own function, because this is a very common operation. So I'm going to define a new function. And stick that there. And return the result. I meant to copy that too. That goes there. And now I can call this function from here. Vec dot vec1 vec2. And I get the same thing. So the last thing I'm going to do with this is I'm going to make one more function. I'm going to pull out this block of code, and I'm going to call this matrix decompose. So I'm decomposing the matrix into vectors. And I'm going to call this MATR. And I'm actually going to stick it here. So I'm going to overwrite mat2 by calling matrix decompose. And so one thing that I need to do here is I need to check my column size instead of my row size, because before I was decomposing here. So now that I'm decomposing here, I want to check the size of the columns, or the height, basically. So okay, good, that still works. And then the last thing I'm going to do is pass an option to decompose this. I'm going to set it to true by default. And then I'm going to add a check. If decompose is equal to true, call this. And that actually gives me the option of rewriting this before I pass it here. So if, for example, I had like a list of matrices, I could pre-process this list and flip it beforehand, and then I could set decompose to false, and that would save a little bit of processing time from having to call this function, because there is a bit of a problem with doing it this way, because I'm looping through all the entries of this matrix twice. I'm doing it once here, and then I'm doing it again here. It would actually be faster to just recall the entries within this loop so that I wouldn't be doing it again. But I prefer not to do it that way because I sort of lose the process of what I'm doing, and I think that would make the function a little bit less readable. So this is sort of how I prefer to do it. If you needed like super efficiency, you could rewrite it, but personally, it doesn't really affect me when I'm just combining two matrices. So I'll clean this up and I'll define a main function. And so now I need to call main and see if that still works. Okay, so now if later in this script, say down here, I wanted to do this again, I just have to call this function. I don't have to copy and paste all this code again. And that's better, but I still have an issue where if I wanted to write a different script and I wanted this script to use this function that I wrote, then I would have to copy and paste these functions into that new script. So one way to make that better is I'm just going to copy and paste this whole file, and I'm going to make a library. I'm going to call it math. And in math, I'm going to get rid of main. I don't need main anymore. I'm just using this file to store my functions. So I'm going to save that, and then back in my main, I don't need to define these functions anymore, but I do need an import statement that says that there is a file in this folder called math, and I want to load the functions in that file, and that way this script knows how to find this function. And before I can call it, well, I'll just go ahead and show what happens if I don't prefix it. I get an error. Basically says can't find the function, so I need to prefix it with what I named it up here, and now I can use it like normal. And so now if I write another script where I need to use those functions again, or I need to dot two vectors, I have to copy this file into the folder. And that's still not ideal because I would have a bunch of copies of these functions and I want them all in one place. So that's where importlib comes into play. I can import a module called importlib. It's built in. It's not a file. It comes installed with Python, and Python knows where to find it. And so I can make a new folder. I'll call it math. I can bring this script into my math folder, and I can import it with importlib. But before I do that, there's some lines I need to add. I need to reference this file on my computer. So I have an example of that here. And it's these three lines, so I could copy and paste these lines. I need to import OS. I'm using OS to expand my home directory, so I don't need to pass a username, and I'm also using it to separate the folders in a file path. And that's different between different operating systems. Windows and Mac, or I'm sorry, Linux and Mac use a certain separator, and Windows uses a different one. So this shortcut will fill in the correct one based on whatever operating system you're using. So if I wanted to point these variables to my new math library, I'd set this to math, and I change my folder to math and the name of my script, and I would also change this to math, and I would change this to math. Right now these are pointing to the module file, which isn't there yet. I'm actually just going to get rid of this. I have all these prepared. So I'm just going to drag those in. And so now this is pointing to this file, which exists in this folder. And so let's go ahead and take a look at that. So at the top of this file I have all my directories, and these are basically pointing to my different libraries. This is this file. This points to a Python library. This points to my math library, and so on. This points to a folder that contains Blender game scripts. Here are some options for executing Blender in batch mode. And here I have a Blender com string that I can build differently for different operating systems, whether I'm using Linux, Mac, or Windows. And here are these import lib lines again, where I'm assigning these variables to load the libraries that are contained in these file paths. Here is a head function, which is basically this. This is what I add to the top of a new script. I can just copy and paste this file and name it like main.py, for example, and then down here I can declare or define a main function. So this points to module, which basically loads all of these custom libraries in one place, and I can set options in here. I can even keep notes in here on, like, if for example I forgot how to do something, I can keep like my own reference, and then my scripts can use all the functions in the different libraries. So here what I'm doing is I'm linking my different libraries together. For example, my Blender library uses functions in my Python library, and so in order for the libraries to kind of talk to each other, I call this function, and this is declared at the top of my library, and when I call this, up here Python is set to none, but what I'm doing with this function tools module is function tools will automatically populate this variable, so that instead of getting set to none, it gets set to this, basically. Whoops. Gets set to that. And then when I call that in here, it won't be none. I can use this function in my Python library. And so that's basically it. That's how I do that. Before I finish, I wanted to show one more thing, and that is how to set up a Blender game file. It's a little bit different. There's a little bit more to it. So here I have this blend file. So I'll drop those into my folder. Um, Here I have a game script that's going to load a game scene. Here I have a load file that's going to call this script. There's my blend, and in this folder I have the game scripts that the game uses when it runs. It's using these 3 scripts to run the game. So I'll go ahead and start this blend file. So in my downloads folder I have a portable version of Blender, so I'm just going to drag in the executable, and I need to make sure that I'm in my working directory, and I want to use a console to do this because I can get printouts and I can get errors if I made a mistake and need to debug basically. So then I'm going to drag in my blend file, hit enter, and this is basically a default scene. All I've done is I've loaded the load.py script, and basically all that does is it points to this build file. And the reason I've done it this way is because if you make a change to a script in Blender in the text editor, you have to reload it for each change. But if you load a load script, then it remains constant and never changes, and I can make changes to this script and save it, and I won't have to reload it. So actually, before I run that, I'll show what's in here. So same thing, I'm loading my module library, and then I'm redefining the names of all these libraries. I'm just making them shorter. And then from the blend game library, I'm setting the engine to the game engine. That's the render engine. I'm making the mouse cursor visible. I'm enabling debug properties, deleting the default cube. I'm loading an empty scene object, and that's going to add an input script to that object so that I can receive keyboard input. I'm going to add a background. I'm going to add an X and Y axis, basically. Then I'm going to add a 2x2 matrix. I'm going to create 4 planes, and each plane is going to represent an entry of the matrix. And on each of those planes, I'm going to load a diff.py script, and that's in here. And that's a script that the game is going to use while it's running. And that looks like this. And basically all this does is it detects mouse movement when the mouse moves right or when the mouse moves left. So I'm adding these value vars, and that way I can change the value of each entry using the mouse. And I'm making the objects clickable by calling this mouse click function. Then I'm going to add a sphere that I can control with WASD, and I'm going to track the location of that sphere. I'm going to track it in this script, mitr.py. That's another game script, and this is a sphere that will represent the transform of this matrix. I'm going to take this sphere, this location, and I'm going to combine it with this matrix and place it in a new location. Place this sphere in the transformed location, and I do that with this script, so I'll show that. And up here I have basically those same functions that I just made. I read the entries of these matrix objects, and then I combine the 2 matrices, and I set the position of my second sphere to the result. So the last main thing that I do is I'm going to create an axis that shows the direction of my matrix, and that's with that script. And all this does is it takes one of the two columns and it retrieves the magnitude of that column. It converts it to a vector basically and retrieves the magnitude and retrieves the direction, and then sets the scale of the axis based on the magnitude, and sets the z direction of the axis based on the direction, which is determined by arctan. So I'll go ahead and run this script to load my scene. So here are the entries of that matrix, and it's sort of like this. And I'm going to combine that with the old transform of this white sphere, and I'm going to get a new transform. And the new transform will be applied to this black sphere. So here, if I click on this first entry and go to my logic editor, this value is 1, this value is 0, this value is 0, and this value is 1. So I have 1, 0, 0, 1, and basically I have an identity matrix. So what that will do is it will place my second sphere in the same position as the old one. Any identity matrix that gets multiplied by a matrix of the same size will result in the same matrix. It's sort of like in algebra, in regular algebra, when you multiply a number by -1, you get the same number back. So with a 3x3 matrix, your identity matrix looks like this. Whoops. It's basically a diagonal of 1s, and you could think of this as the x-axis of a 3D world, and the y-axis and a z-axis. It sort of corresponds to this. So this axis points towards the x direction. Its y value is 0 and its z value is 0. The y-axis points up in the y direction and its x and z values are 0, and same as the z-axis. So if I run this, I've debugged the values of my matrix. So starting with 0, that corresponds to this one, 1 corresponds to this one, 2 is this one, and 3 is this one. So if I move my sphere, then this it's sort of like the shadow, it sort of follows it around, and that's because I have an identity matrix. So let's say I wanted to form a matrix that rotated a 2D point by 90 degrees, then I want to rotate my x-axis this way and my y-axis this way. So this first column corresponds to the x-axis, and this column corresponds to this y-axis. So if I change the x value of the y, you can see this point start to transform. And if I want to rotate it 90 degrees, then I want to set this x value to -1. This is the x-axis, obviously, and this is the y-axis. This is 10, and this is 10, -10, -10. And so I want to pull my y value down to 0. That's the y value down. That's the y value of my y-axis. So I can see how that affects the transform of this point in real time if I move my object around. So now if I rotate my x-axis, I'll set the y value to 1 approximately, and I'll set the x value to 0. And now what I have is a 90-degree rotation. And so you can set this to whatever you want it to be and get the resulting transform in real time. And this is the kind of thing you want to do with math operations. If you're having trouble understand how they work, it can take a concept and make it a little less abstract and a little more something that feels like that feels real and feels like you can touch. You can do it with matrices, but also vectors, and pretty much anything can be represented graphically. And so that's pretty much it. That's the end of this video. So I hope you enjoyed it, and thanks for watching.